Hey everybody, how's it going? Hope you're all doing great today. So my name is Amelia. I use she, her, they, them pronouns, and I work for Microsoft as a cloud advocate focused on games and spatial computing. But I'm actually here to talk about what I was doing before Microsoft, which was working on a new games hardware platform where we were trying to figure out, we built this new hardware with our own hands. We don't quite know what games work for it yet. So we were spending a lot of time building a prototype or two a week to explore different interfaces and see what was fun, what wasn't fun, what we could conceivably actually commercialize. And in doing this, we ran into a really classic game design problem, which is if you have a prototype and it is fun and it is working, that is immediately obvious within 30 seconds of playing it often. But if it's not quite working, it's really hard to figure out if it's because it is not good and you need to leave the prototype alone, or if it's because you just didn't spend enough time polishing it and getting it to that point where you could see how good it was. This is where, like, a lot of types of games, you can usually prototype them with paper components. Even if it's a digital game, you can use cards and dice and paper things. But because we were specifically working on these twitchy action games and exploring like novel hardware interfaces and thinking about like how do you tactily interface with the game, that put us in the realm of game designers called GAMEFEEL. The sort of art of tuning, what is this moment-to-moment enjoyment of interacting with this digital system? In a 10-minute talk, I don't really have a lot of time to get into what GAMEFEEL is or how you deal with it. Here are a bunch of references you can look up. I particularly recommend Ayla's talk from last year's Bang Bang Con because Bang Bang Con is awesome and Ayla's awesome and her talk was awesome. But long story short, that meant we couldn't just reduce the scope of our prototypes by making them lower fidelity. We actually needed to figure out, well, how can we polish them more quickly and make game design happen faster? And so the way we cut through that Gordian knot, as you might be able to guess from the title of the talk and the first slide, was with MIDI controllers. So this here is a Korg Nano Control 2. Costs about $50 online. Bunch of knobs and sliders, connects to your computer by USB, and you can control them use them to control MIDI interfaces. So we would take our games that were written in Unity and wire up all of our physics constants and all these other magic numbers that we needed to tune to knobs and sliders on this MIDI controller. So what did this actually get us? A whole bunch of things. The first is making it so we could much more effectively tone in on proper values. So if you think about the naive way you do something like this, you would have a value in your code or maybe like a config file, you would set it to a value, you would run your game, play it for a bit, go back, make some changes, play it again. That's really, really slow. Unity is a little better because it has the sort of visual inspector window so you can change the value while you're playing, but you're still fundamentally in this state of bouncing between playing and editing. Whereas when we have this actual MIDI controller where you can tune the values with your hand, it can become much more immediate. And actually, in many cases, depending on the game and what we were doing, like we would find we could be playing the game with one hand while tuning it with the other, which gets you immediately into this flow state of honing in on what the right values are and what feels right. It also helped a lot when we got to much more complex situations involving interdependent variables. So we spent a bunch of time on this prototype that was a like cartoony kart racer, kind of like Mario Kart. And for that, we were tuning values like acceleration and max speed, not velocity, and your turn radius. And while each individual value is really important, what's a lot more important is the relationship between the two. And that's really hard to model when you're changing one value at a time. We played around a little bit with, maybe instead of tuning the acceleration or the max speed, you're tuning a variable that represents the ratio between them. But that's way above my pay grade to deal with. And instead, it was much easier to say, hey, look, we have this physical thing that has 3 different sliders that I can control all 3 of them with my fingers at the same time. What if I could do that and then very, very quickly and much more like intuitively suss out like what is the actual relationship between these variables? So that was awesome. It's also really fun. It makes you feel like this DJ code wizard while you're doing it. I love, my collaborator used to make all of these sort of proper mise en place before starting a tuning session where they would write out, what is each variable they're tuning and how does it relate to the physical board. And I think this is not just frivolous. I think this actually really, really matters because game design is a creative art and something that can get you into this playful state where you're willing to explore and try new things is actually really, really important to doing good work. But also on a more numerical level, it actually did concretely help, because humans have a lot of really bad cognitive biases around numbers. And so it's really unlikely that the proper value for like friction of an object is going to be a nice, beautiful integer, or like goes 1 or 2 places in the decimals. But if you're just typing numbers into your IDE, you're going to be biased against using those. Where if you have this nice analog interface, you're going to hone in on what actually feels right rather than what looks right in the text editor. Worth calling out, though, that this is all a bit of a hack. Some of you may be familiar with Brett Victor's work. This is an example from his talk, Inventing on Principle, where he hypothesizes this sort of Super Mario Brothers style 2D platformer and uses this sort of IDE he has built or hypothesized that as you change like your Y jump velocity, you can see it happen on screen as you sort of abstracted away the variable of time. And so ideally, this is the sort of stuff we would be dealing with, like the fact that you can use design tools to sort of so cleanly cut through complexity and just take your entire possibility space and lay it bare. That's really, really cool, and what I would love to see game design tools and other design tools go. But until we reach that point, a MIDI controller is like $50 and does the job pretty well. So concretely, what did I actually do? So the dirty secret that I learned as I started looking into this is game designers have been using MIDI controllers forever. They just don't talk about it. It's not like they're afraid to let their secret out. They just don't blog about it. They don't give talks about it. It's just not part of the culture. So the only thing I could really find was this talk that blog post that William Cheer posted in 2015 when he was working on his beautiful game Manifold Garden, about how we used a Nano Control 2 to do that. So I basically took his work, took sort of his design ideas and formalized them into this Unity library, where if you have a Nano Control 2 and your game is in Unity, you just drop this into your Unity project and it gives you a lovely UI to set things up. Saying that a piece of tech just works is really dangerous, I'm aware, so I'm going to attempt to give you a live demo. I couldn't easily set up the custom hardware we were working on. It's a major pain, so this is just a very simple Flappy Bird demo. I can click the mouse and you flap. Exciting. But if I go to the MIDI controller mapping window that I built, you can see here's a Nano Control 2. They also make it in black, so we have a dark mode. Each of the knobs and sliders has a space where you can add mappings. So this one, we already have a mapping in place to the bird game object, which is the player's bird in the scene. Unity uses what's called an entity component model. So each game object has a bunch of components attached to it that each control behavior for like rendering the 2D sprite, for doing rigid body physics, for doing collision detection, and the bird is our custom component that handles flapping. And from there, this drop down is dynamically going into that bird component and finding any value that we could conceivably control with the controller. So in this case, just up 4 is how much you jump. The current value in the game is 100. Range is just when the knob is at 0, that value is 0. When it's all the way at the top, it's going to be this value. So if the slider is up at full, it's going to be 1,000. So the value for the bird is going to be 1,100 instead of 100. So with that set, if we then go to play the game and I grab my MIDI controller, whoops. So I'm playing as normal, but then as I turn this knob, whoops, maybe our jump's a little bit too high, but it works. So I don't have a lot of time, but I do want to talk about one design decision of all of them that is really, really important, which is these drop downs to show you the different components. I can also show it to you in the side here. You can access it this way. So when I built this, my intention was, great, the amount of time I'm going to spend metaprogramming, grabbing all the components and then grabbing all of the editable properties, that's going to be less engineering time than I will probably lose to typos if these are just empty boxes you can type in, which I think is true. But also, this turned out to be a way more important design decision, because now that this is, like, if this was 2 empty text boxes, this would be a very, like, purpose-built tool that I would come to and I would say, this is what I want to tune, I care about these variables, I'm going to do that, and then I'm going to leave. Whereas now, this is now a tool for exploration, where I can look around and say, well, what things can I actually change? And this now becomes not just a tool to allow me to do things more effectively, but again, it puts me in the space for play where I can explore the possibility space and see what I can do. And this is going to help me be creative in a way that the tool otherwise wouldn't have. Like, what happens if I play around with the angular velocity of the bird? And so I think that is actually really important. When you think about making tools for design, for game design, for engineering, usually we're hyper-focused on augmenting human productivity and making things and tools that let us do tasks and jobs faster. Whereas, again, game design is a creative practice. I'm much more interested in thinking about how to augment human creativity and how can I build this tool to enable me to come up with game designs and make decisions that I otherwise wouldn't have even considered. Or to put it one more way, pianos and hammers are both really effective tools if you're a composer or a building contractor. But there are a lot of hammers in the world and not enough pianos. So if you're someone building design tools, you should make more pianos. Thanks a lot.